Now here the component is defined, only one component is used in the full adder. It may be used two or more times, but we will define it only for one time. So now again the syntax is component is declared, architecture started, architecture struct is, then we have initiated the component, we have mentioned the signals which are used in the components, component is declared, description for port is done, and the syntax is end component followed by the semicolon. Okay, now how these components are interconnected, that is nothing but how exactly the structural or how exactly the structure between the components, that is nothing but the structural modeling, interconnection between the components. So how these interconnections are, for that we need to declare the port mapping. Now how the port is mapped. Okay, so let us begin. So what is the syntax? Begin component 1 half adder 1, that's why it is meaning half adder 1 colon, which is nothing but a half adder component HA, that is the component name I have mentioned here. HA is the component name, and for this component there are how many ports? 2 input ports and 2 output ports. So for this half adder 1 I have to define the input and output port. So A, B are the input ports for this half adder 1, as I have seen in the diagram also here, and port mapping is AB, S1 and C1. These are the signals associated with half adder 1, interconnections of half adder 1. Now let us define the second port mapping, that is for half adder 2. Again the component is half adder, so again the data will be taken here. Component is half adder, port mapping for it, 2 inputs, 2 outputs. Now for inputs for half adder 2 is S1 and C in, so I have written here inputs S1 and C in, output is sum and carry C2. Here we are talking about the half adder 2. Okay, now what we can do, the semicolon is there, so port components are declared here. You may think that there is another component OR gate, so what you can do, you can declare one more OR gate in the component section, component OR, in which you can define the OR gate, or simply it is inbuilt in the IEEE library. So I am writing here Cout, that is nothing but the final carry. This is Cout. Cout is nothing but C1 or with C2. So you know that here in the interconnection, in the structure of this full adder, Cout will be the combination of C1 or C2. So this arrow indicates towards Cout, means what? First of all C1 or C2 is calculated and the value will be assigned to Cout. Okay, so that is nothing but the total structure of the full adder in the structural modeling case of the VHDL. And after defining the whole structure, you have to end struct. So this is the architecture name was the struct. Okay, and I ended the structural, and architecture struct was defined for the entity FA. Okay, so that's it. And so let us start with the data flow modeling of the same example, full adder. Now what we have here is the data flow modeling, which will be considering the how actually the data is flowed, or the how for a variable concurrent statements, how the value is assigned for a particular variable through concurrent statements. That is nothing but the data flow modeling. So let us start. The code is written here. So let us start by one. We have already seen the library IEEE is selected, and we are going to use IEEE.standardlogic 1164.all library. First of all, I will declare the entity. So entity, my entity name here is somewhat different than what we have used in the structural modeling. So entity FA underscore DF is, that is nothing but entity full adder underscore data flow modeling, that is DF is. So what is the name of the entity? Entity name is FA underscore DF. You can use numbers also in the entity name. So entity is all about the interface, inputs and outputs. So I will define the ports, input ports and output ports. So port A, B, C, A, B, C in, that is the input port for the data flow modeling here, input side. Here is the output side. Okay, so it will be input bit type data, single bit will be there for A, B and C in, and output will be S comma C, that is in bit sum, and the final carry C. This will be out bit type of data. Okay, only single bit is there, 0 or 1, that is in the standard logic. And entire entity is defined here, port inputs and outputs. So we'll end the entity by writing the syntax end followed by the entity name and semicolon.